A reading of Electric Gravity in an Electric Universe by Wal Thornhill, Part 1 of 2. The article begins with a quote by Sir Oliver Lodge. Quote, "If a special geometry has to be invented in order to account for a falling apple, even Newton might be appalled at the complications which would ensue when really difficult problems are tackled." End quote. Gravity is the most familiar force. We are subject to it every day of our lives. Newton gave us his law of gravity, which describes its effects but doesn't explain it. "I frame no hypothesis," he wrote. Einstein wasn't so prudent when he introduced his postulates. Unfortunately, his unreal geometry doesn't explain gravity either. The usual demonstration, using heavy steel balls on a rubber sheet to represent gravity wells, relies on gravity as its own explanation. The fact that we do not understand gravity in this space age should cause alarm. Our cosmology, our view of our situation in the universe, is based on a mystery. The Big Bang is a monumentally expensive work of fiction. We missed a chance to include electricity in astronomy in the early 1900s. Birkeland was performing his electrical Little Earth or Terrella experiments in Norway, and Gauss and Weber were discovering the electrical interactions of matter. Today, physicists labor under misconceptions about the nature of matter and space, the relationship between matter, mass, and gravity, the electrical nature of stars and galaxies, and the size, history, and age of the universe. So when astrophysicists turn to particle physicists to solve their intractable problems, and particle physicists use it as an excuse for squandering billions of dollars on futile experiments, neither party recognizes that the other discipline is in a perilous state. Quote, "After all, to get the whole universe totally wrong in the face of clear evidence for 75 years merits monumental embarrassment and should induce a modicum of humility." End quote. Quote, "The standard model of particle physics would appear to fail in nearly every possible way, and all of its failures seem to stem from the early 1930s. By all indications, science seems to have taken a wrong turn about this time. After 300 years of progressively simplifying the description of the universe with fewer entities and simpler laws, it suddenly turned the other way, with complexity and entities multiplying like rabbits." End quote. Quote, "We are about to enter the 21st century, but our understanding of the origin of inertia, mass, and gravitation still remains what it has been for centuries. An outstanding puzzle." End quote. How has this situation arisen? In the 20th century, technology perfected wireless communication and computers and got man into space, while fundamental science fell deeper into a black hole of complication, illogicality, and metaphysics. I consider the principal cause has been the usurping, since Einstein, of natural philosophy and physics by theoretical mathematicians. Meanwhile, Einstein, perhaps to his credit, remained skeptical of his own work. I have always found it instructive to read what past illuminaries of science thought of a radical new idea. The free exchange of opposing opinions is later stifled by the bandwagon effect. Science, like all human endeavors, is subject to fads and fallacies. When controversy was still tolerated over Einstein's theories, Sir Oliver Lodge, a noted fellow of the Royal Society, wrote in Nature on February 17, 1921, quote, "What is really wanted for a truly natural philosophy is a supplement to Newtonian mechanics expressed in terms of the medium which he suspected and sought after but could not attain, and introducing the additional facts, chiefly electrical, especially the fact of variable inertia, discovered since his time. If we could understand the structure of the particle in terms of the medium of which it is composed, and if we knew the structure of the rest of the medium also as to account for the potential stress at every point, that would be a splendid step beyond anything accomplished yet. End quote. This is precisely the electric universe view. Natural philosophy has withered in its confrontation with the modern fashion of mathematical metaphysics and computer games. Most of the discoveries now are merely computer-generated virtual reality, black holes, dark matter, dark energy, etc. The computer models are constructed upon a shadowy kernel of ignorance. We do not understand gravity. Einstein, in his special theory of relativity, postulated there was no medium called the ether, but Maxwell's theory of electromagnetism requires it, and Sir Oliver Lodge saw the ether as crucial to our understanding. So Einstein, in a stroke, removed any possibility that he or his followers would find a link between electromagnetism and gravity. It served the egos of his followers to consecrate Einstein's ideas and treat dissent as blasphemy. Quote, "Sometimes a concept is baffling not because it is profound, but because it's wrong." End quote. Decades later, Paul Heil wrote in Scientific Monthly, May 1954, quote, "The more we study gravitation, the more there grows upon us the feeling that there is something peculiarly fundamental about this phenomenon to a degree that it's unequal among other natural phenomena. Its independence of the factors that affect other phenomena and its dependence only upon mass and distance suggest that its roots avoid things superficial and go down deep into the unseen, to the very essence of matter and space." End quote. This sentiment has been echoed down to the present, but few are listening. The problem is worsened by the particle physicists who indulge in their own virtual reality, inventing virtual particles to transmit forces. If they could understand the structure of the particle in terms of the medium of which it is composed, and put flesh on the metaphysical bones of quantum theory, we should be much further advanced. Sir Oliver Lodge deserves to be heard once more. Quote, "It may be that when the structure of an electron is understood, we shall see that an even-powered stress in the surrounding ether is necessarily involved. What I do feel instinctively is that this is the direction for discovery, and that what is needed is something internal and intrinsic, and that all attempts to explain gravitation as due to the action of some external agency, whether flying particles or impinging waves, are due to failure. For all of these speculations regard the atom as a foreign substance, a sort of grit in the ether, driven hither and thither by forces alien to itself. When someday we understand the real relation between matter and ether, I venture to predict that we shall perceive something more satisfying than that." End quote. In 1950, Faraday performed experiments trying to link gravity with electromagnetism that were unsuccessful. However, his conviction remained. Quote, "The long and constant persuasion that all forces of nature are mutually dependent, having one common origin, or rather being different manifestations of one fundamental power, has often made me think on the possibility of establishing, by experiment, a connection between gravity and electricity. No terms could exaggerate the value of the relation they would establish." End quote. Faraday's estimate of the importance of such a connection still stands. Today, there are a number of scholars pursuing this obvious line of inquiry. After all, the electrical and gravitational forces share fundamental characteristics. They both diminish with the inverse square of the distance. They are both proportional to the product of the interacting masses or charges, and both forces act along the line between them. Gravity acts in proportion to the mass of an object. What do we mean when we refer to mass as an object? One of the most astonishing features of the history of physics is the confusion which surrounds the definition of the key term in dynamics, mass. Early in the 20th century, numerous textbooks equated the mass of an object to its weight. That equation led to confusion because it doesn't explain why the mass of an object we measure on a weighing machine, gravitational mass, is identical to the mass of that object when we push it, inertial mass. When it was found that atoms are composed of charged particles, there were attempts to explain mass in terms of electromagnetism. Henri Poincare wrote in 1914, quote, "What we call mass would seem to be nothing but an appearance, and all inertia to be of electromagnetic origin." End quote. It makes good sense that the equivalence of gravitational and inertial mass should be explained by the electrical structure of matter. However, it is not the philosophical concept of mass, but its mathematical treatment that occupies physicists. Einstein's famous equation, E equals mc squared, demonstrated that mass and electromagnetic energy are directly related. But mystification resulted when the earlier concept that related mass to quantity of matter was unconsciously substituted. Textbooks and encyclopedias today slip unnoticeably into the error of using the words mass and matter interchangeably. A NASA educational website tells us that, quote, "mass is a measure of how much matter a planet is made of," end quote. It shows that the confusion of mass with quantity of matter infects astrophysics. The consequences are profound for cosmology. The mass of a celestial body cannot tell us about its composition. We cannot say what the sun is made from. Another example is comet nuclei, which are electrically charged bodies. They register masses that should have them constructed like an empty sponge, yet they look like solid rock. It is their appearance, together with the recently recovered high-temperature minerals, rock particles, from a comet, that give the accurate picture. Comets and asteroids are fragments of planets. They are not primordial. Quite the reverse, in fact. This inexcusable philosophical muddle over matter and mass has given rise to violation of the fundamental physics principle of no creation or annihilation of matter. It has allowed a miraculous cosmological creation story to gain currency, known as the Big Bang. Notions of vacuum energy and of particles winking in and out of existence in the vacuum of space are similarly miraculous. The simple fact is that we have no concept of why matter manifests with mass. But when we apply force to a body, how is that force transferred to overcome inertia? The answer is electrically, by the repulsion between the outer electrons in the atoms closest to the points of contact. The equivalence of inertial and gravitational mass strongly suggests that the force of gravity is a manifestation of the electric force.